Hello and welcome. My name is Chris and I'm going to shortly explain what natural cities are and how they can be generated. Next to this presentation there are two tutorials taking you step by step through the process of generating natural cities and how you can analyze them afterwards. So, first of all, what are natural cities exactly? Natural cities refer to human settlements or human activities which are naturally or objectively defined. They can be seen as natural borders to cities or large villages. Administrative borders, for example, are defined by the government or municipality and are not always, or actually most of the time, not corresponding to the actual city edges. The natural cities are not defined by a government or municipality, but by large geographic information datasets. These can be different types of data, like for example street junctions, nighttime imagery, geotagged social media posts, or point of interest data. Note that the data used might yield different results. There are much more junctions than points of interest in a city, thus junctions will most likely be more accurate for defining city edges, but point of interest data might be more accurate in showing high density activity data. Natural cities also vary depending on the scale used, because it's based on wisdom of the crowd's thinking. Therefore, optimally, natural cities would be based on the data of the entire world. But that's not feasible yet computationally, so therefore the minimum size of data used for a representative set of natural cities would be at least for an entire country or county for large countries. A head-tail-breaks classification is the main driver behind defining natural cities. There's much more rural area than urban area, which is why head-tail-breaks is used. It separates the tail, the rural area, from the head, the urban area. Finally, as mentioned before, natural cities are defined bottom-up from big data instead of top-down administratively. The first tutorial is showing how natural cities are created from nighttime satellite imagery. This is excellent data for a large scale, but for smaller scales it's not quite accurate enough. It is based on the notion that human activity and density is higher where there is more and brighter light at night. Darker areas are considered to be rural or in the tail, and brighter areas are urban or in the head. In the image shown, you can see how a natural cities dataset would look like if it's generated from nighttime imagery. There are some things to think about when using nightlights. For example, industrial areas are much brighter at night, specifically, and therefore much more represented in this case. As a direct example, the oil drilling platforms in the North Sea actually show up as a natural city. You can see them before the west coast of the Netherlands. The second tutorial is showing how natural cities are created from OpenStreetMap data, which provides much more data than satellite imagery and thus can be much more accurate. This also means that it's slower to process and using larger data sets might be a problem. These natural cities in the tutorial are based on road intersections, where many intersections close together indicate urban settlements. Three main steps are shown in this slide. First, a triangulated irregular network is constructed, then the tail is separated from the head, and finally the data is dissolved to form the natural cities. The natural cities can be studied after they are created. If they are generated correctly, for example, they will show a long-tailed distribution, with many more small natural cities than large ones. Next to that, they can be visualized with head-tail breaks showing the different sizes or categories of cities effectively. For the Netherlands, for example, the distribution of large, medium and smaller cities can be investigated. It also becomes apparent that the large cities in the Netherlands are clustered very much, while the medium cities in yellow and the smaller cities in blue are much more evenly distributed. The second tutorial also shows a deeper analysis by applying the natural cities calculation recursively on cities already defined. For example, for the Netherlands, after natural cities are defined, Amsterdam can be located. The natural city representing Amsterdam can be taken, and within that city the junctions can be analyzed again in a similar way. In this way you end up with another set of natural cities, or hotspots in this case, for within the city. That's kind of shown in panel A. If the data is detailed enough, you can even do that once more. So in panel A it is done on the city of Amsterdam, and in panel D it is done on the hotspot of the city of Amsterdam, and it shows the center of Amsterdam, where the absolute densest point is on the central station actually. Thank you for listening to my short presentation accompanying two natural cities tutorials. Good luck with the tutorials and have a great day.